Hey everybody, this is Chapter 1, Section 1. We're going to do this section in two parts, so this is Part A. This section is titled Variables and Expressions, begins on page 4. We're going to start with some terms and definitions. A quantity is anything that can be measured or counted. So if there's something you can have a pile of, for example, I can count 4 apples. So 4 would be the quantity. There's two types of quantities in algebra: constants and variables. And we'll have both of the definitions of those as well. A constant, those are quantities that cannot change value. They can't be anything else. For example, 4 is a constant. A 4 can't be a 7, a 4 can't be a 9. The only thing that a 4 can be is 4. Its value stays constant. It can't change. The word vary means to change. So a variable is a quantity that has a value that can change. It's kind of the opposite of a constant. In math, variables are usually letters. For example, x is the most common variable that we use. X can have a different value if you put it in a different problem. For example, in one problem, x might equal 3. In another problem, x might equal -7. The value of x can change. It can stand for different numbers, so we call that a variable. More definitions. There are two types of expressions in math: algebraic and numerical. Now, in that word algebraic, you see algebra. An algebraic expression has at least one variable in it. Algebra is all about variables, so algebraic means variable. For example, x plus 7. That expression, x plus 7, has a variable in it, the x, so that is a variable, an algebraic expression. Numerical expressions have numbers and operations, but they don't have any variables in them. For example, 14 minus 3. There's no variables in there. It's all just numbers, the 14 and the 3, and an operation, subtraction. There's no variables in that anywhere. We've been using this word expression. An expression is something that does not have an equal sign. The two examples we've got on there, the x plus 7 and the 14 minus 3, there's no equal signs anywhere in those problems, so we call those expressions. If there's something that does have an equal sign, we call that an equation. We'll talk more about equations later on in the chapter. Math is just like a foreign language. A lot of what we're going to do in this section is we're going to translate. We're going to turn math expressions into words, and we're going to turn words back into math expressions. In a foreign language, you have to be able to translate in both directions. For example, I can translate the English word hello into the Spanish word hola. I can translate the Spanish word gracias into the English words thank you. You have to be able to translate both directions. Same thing in math. The rest of this lesson is all about translating math. Start to take a look at some of the problems that we're going to have to do in this section. Example 1a. I need to translate those words into an expression. Well, 4 is going to be the same if it's in a sentence like this or if it's in an expression. So I just put the number 4. A number p is my variable in this problem. A number p just means that can be any that can stand for any number. So that's my variable. And the word plus turns into the plus sign when I translate into expressions. So the words 4 plus a number p turns into the expression 4 plus p. Another example of that, example 1b. 23 less than x. That's in words, and I need to turn it into an expression. The number 23 just stays 23. X is my variable, so it stays x. Less than, what operation you think less than is? Well, less than is subtraction. But there's kind of a tricky thing to this one. The word than, see right here, the word than does something special in these problems. And I put this stuff in exclamation points so that you make sure you write it down and understand it. Every time you see the word than, a siren should go off in your head. The word than means backwards. Less than does mean subtraction. We were right about that. But the other two parts of the problem have to be written backwards. So instead of 23 minus x, the correct answer is x minus 23. Because that word than tells us that we have to write things backwards. Another example, example 2a, 3 of a number x. As an expression, I've got 3, a number x is my variable, and the word of, if it's by itself, means multiply. So of, I'm going to put a dot here to mean multiplication. We don't use x for the multiplication symbol anymore, because it's too easy to confuse the variable x and the operation x. If I used x to mean multiplication, then this problem would be 3xx. That gets confusing. It's hard to figure out which one is which. So I'm not going to use x to mean multiplication anymore. There's 3 ways I can write multiplication. With a dot, like I did up there. I can just put the two parts together with nothing in between them. That also means multiplication. And I can use parentheses for multiplication. 3 different ways to represent multiplication. The dot, 2 things right next to each other, and then with parentheses. One more example here in part A. Example 2b, the quotient of n and 8. N's my variable, so it stays the same. 8 is just a number, so it stays the same. Quotient means division. And I see the word of again, but this time it's not by itself like it was in the last one. Anytime I see of paired with another word, like sum, difference, product, or quotient, I need to look for the word and. We've never seen anything like what I have written down here. Division sign, N8. We've never seen anything in that order. The operation has to come between 2 things. And so if I see of matched up with something else, I also have to look for the word and. The symbol then, the operation, goes where the word and is. So the correct answer, n divided by 8. That's the end of part A. I'll see you for part B.